Hello, welcome to lab series number 12. This is the live labeling part 2 introduction video where we're going to make a 100 milliliter copper sulfate solution using a 2 molar stock concentration. So in this lab, the purpose of this is to get hands-on experience with creating a solution using the dilution formula from a stock solution. So in this case, we will be watering it down, diluting it to a specified concentration that is specified by our answer sheet. Let's get into it. All right, so here I have the student guide that will be at all lab stations. It'll be the same, and then at each station, there are 5 different stations. There will be a different student card using different volumetric flasks and different desired concentrations. The guide kind of gives us an intro and objective background, kind of color-coded dilution formula, shows what the answer sheet will look like and what to do on that. And then we have our procedure and our post-lab questions. The first thing we need to do, let me zoom in a little bit, is our student guide, and we need to calculate for our solution. At this station, now this station will not be active, so if you are actively doing this, please do not copy what is going on here, as you will not have the same concentration and likely not the same volume at your station. For this station, we are to make 100 milliliters of a 0.33 molar copper sulfate solution. That is our goal. And we are starting with, as you saw, a 2 molar copper sulfate solution. So we need to do some math, and we need to figure out how do we use this to get to this. So we're going to use our dilution formula, which on our guide is right here, which is M1V1 equals M2V2. The concentration of our stock solution is M1, and we know this is 2 molar as it is listed on the label of our stock solution. So we will label this 2 molar. We are solving for the volume of our stock solution. Our desired final concentration is, for this station, 0.33 molar, and our desired final volume is 100 milliliters. So we use this information and plug it into our formula, M1V1 equals M2V2. Our M1 is 2 molar. We do not know V1, that is what we are solving for. Our M2 is 0.33 molar, and our desired concentration V2 is 100 milliliters. So we're going to solve by the variable. There is multiplication occurring between these two, so we need to do the opposite action of that. And the opposite of that is 2 molar. So we divide by 2, and this will cancel this out to 1. Whatever we do to one side of the equation, we must do to the other side as well. So we'll divide this by 2 molar as well. And what we see here is we have molarity on bottom and molarity on top. This is going to cancel this unit out and tells us that our answer will be in milliliters. From there, we just solve it. 0.33 times 100, which is 33. Then divide that by 2, and that will be 16.5. So you do it just like you read a book. We read a book from left to right, and then we read the book down. So we do the top first, 0.33 times 100, and then we read it down and divide that by 2, and our V1 is 16.5 milliliters. So this is the information we need to make our solution. This area here is at the end of the lab to answer the post-lab questions. So we're about to get into making this solution. So what we have found out is in our volumetric flask, which is the best tool for using making solutions, we are going to add in first 16.5 milliliters of our stock solution. That'll be a little bit right there. And then we are going to dilute it with water until we reach our 100 milliliter mark. At the conclusion of this, the solution will now have a concentration of 0.33 molar. All right, so here we have some of our materials, and we are ready to get started. We have our stock solution, 2 molar copper sulfate. We have some distilled water. We also have some distilled water in a wash bottle. And then we have our volumetric flask. And the reason why this is an effective tool is because the whole purpose of this entire vessel is to measure at this graduation mark here, which is 100 milliliters. This is more accurate than a bottle such as this. It's more accurate than a beaker. It's more accurate than a flask. It's even more accurate than a graduated cylinder. Because those are, for one, they're larger, so it's harder to be as accurate, and they have several graduation marks. This is designed only to measure 100 milliliters. So every bit of technology, every bit of manufacturing that went into designing this is all about that one line. So we're going to get started, and as we figured out a few moments ago, we need to add 16.5 milliliters of our stock solution. To do this, let me send this out of the way. I'm going to use a graduated cylinder. Here's our 15 mark, our 15 milliliter graduation. 16 is above that, and 17 is the line above that. So we're shooting for the bottom of that meniscus to be in between the 16 mark and the 17 mark. What I like to do is to get this close by pouring it in. So I do not want to overshoot it, but it would take forever to do it with a pipette. So there we're at about 12. I'll add a little more. So I'm pretty close here. So the goal is to get between these two graduations here. So we got 15, 16, 17. We need 16.5, and specifically the bottom of this meniscus as well. So now I'm going to use a transfer pipette to finish it off. By doing this method, I can slowly add my solution so I do not overshoot my target. We are reaching the 16 mark now. Remember, not the top of the meniscus. So right now, the top of our meniscus is above the 16, but the bottom is not there. And we want to measure at the bottom. So there's our 16. So we need to go up a half a milliliter more. If I know I'm dead on 16, I know that this point on a 1 milliliter pipette is a half milliliter. So I can be pretty accurate by drawing up a half a milliliter into my pipette and putting it in. So at this time, our bottom of our meniscus is right at that 16.5 mark. We are ready to continue. I'm going to use a funnel to prevent spills. And now we'll add our concentrated 2 molar solution to our volumetric flask. So here's the concentration of this solution is still 2 molar. We have not diluted. So now as we add distilled water to it, it is going to slowly dilute until we reach our desired mark. So every drop we add takes this away from 2 molar. So a little bit added to it, we start seeing 1.99, 1.98, 1.97, 1.9, 1.8, 1.7, and so forth. So we will be diluting it. So I'm going to add water till we get kind of close to this point here, and then I'll fill it off with a wash bottle. So here's our DH2O. So we are diluting. We're actively diluting it, and as we add this water, you'll see the color change. Be careful with the thing, it might vapor lock, so it's kind of beneficial to hold it up to allow that airflow to occur. So as you can see, our level is here. We are aiming for the bottom of the meniscus to be at our graduation mark. So I got it close by pouring with a beaker, and then we will finish it off with some deionized water. I don't know. Does that help a little bit? Just going to slowly bring it up to our graduation mark. Again, we're looking at the bottom of that curve, the bottom of that meniscus, to be dead on. So it almost appears to be over the line, but the bottom of the curve is dead on. Our final step is we're going to cap it, and then we are going to invert about 5 times. So this will allow the solution to mix. So we have made our solution. This is 0.33 molar copper sulfate, 100 milliliters. The next part of the assignment is we will label a reagent bottle to store this in. So we're going to take some labeling tape, apply that here. There are 4 components to our label that we want to have. We want to have our initials, we want to have our date that it was made, we want to have the concentration, and we want to have the identity. So we'll initial first, we will initial, then we will date, then we will add our concentration, and then we'll add our identity. So we've created our label for our storage bottle for this, for our working solution. And then we will add it. And cap it. So at this point we have completed the assignment. And the instructor will come over and check us off, and we'll check the concentration of the solution, most likely using spectrophotometry or something of that sort. All right, so that is it for our live labeling part 2 lab activity. We'll see you for episode 13.